Now let us first see formation of electrovalent or ionic bond. Now as we know that electrovalent bond is formed by complete transfer of electrons from one atom to another. Okay, and this one atom will be metal, and the electron is transferred from a metal to a non-metal. Why? Because we know that metals have a tendency to lose electrons, whereas non-metals have a tendency to gain a electron. So this transfer of electron occurs from metal to non-metal. And why this transfer occurs? So as to complete their outermost orbits by acquiring the stable noble gas configuration. So this transfer occurs so that the atoms can acquire the nearest stable noble gas configuration. For example, we can see the formation of NaF molecule. Now in case of the NaF molecule, as you might be knowing, the configuration of Na, if we see just the distribution of electrons, the distribution is 2, 8 and 1. If we look in fluorine, the distribution is 2 and 7. So we know if it can lose this one electron and if it can gain this one electron, then the both of these metals and non-metals can acquire the stable nearest noble gas configuration. So what will happen? This will lose this electron and this will gain this electron. So this electron will be transferred from Na to F. Now in this process, when Na will lose the electron, so it will become a positively charged species, which is now called as cation. Similarly, when fluorine will acquire this electron, it will become F minus, which is anion, and force of attraction between this cation and anion is called as ionic bond. Now if I show you the electron clouds, and we know that cations are smaller in size and anions are larger in size. So this is Na plus and this is F minus. So this is the electron cloud of Na plus, this is the electron cloud of F minus. So you can see that when NaF molecule is formed, it is formed due to force of attraction between this positive and this negatively charged species, whereas you can also see that these electron clouds are not overlapping, whereas in case of the coordinate or covalent bond, you can see that there the bond is formed by overlapping of orbitals, whereas if you see here the electron clouds of Na plus and F minus, they are separate, they do not overlap, but a force of attraction exists between the positive and negative charge, and this electrostatic force of attraction is called as electrovalent or ionic bond. Similarly, we can see other examples also. For example, formation of MgO. Now we know here Mg is having a distribution of 2, 8, 2, whereas oxygen is having a distribution of 2 and 6. So if these two electrons are transferred from Mg to O, then this will acquire the noble gas configuration, this will also acquire the noble gas configuration. So here we can say that electrovalency of Mg is also 2, of oxygen is also 2. Similarly, if we see another example, we have calcium chloride. Now in calcium chloride, we know there is 1 calcium and 2 chlorine. Now calcium is having a distribution of 2, 8, 8, 2. Chlorine is having a distribution of 2, 8, 7. This chlorine will also have a distribution of 2, 8, 7. So if this one electron can be transferred to this chlorine and one electron can be transferred to this chlorine, then they both will acquire the noble gas configuration. Similarly, this calcium will also acquire the noble gas configuration. Now since 2 electrons are being transferred from calcium, so we can say here that electrovalency of calcium here is 2, whereas if we say electrovalency of Cl, that is 1, because each chlorine is taking up only 1 electron to complete the noble gas configuration. So students, how can we define electrovalency? We can define electrovalency as a number of electrons lost or gained during the formation of an electrovalent bond. So whatever the number of electrons are involved, be it during the loss or during the gain, that loss or gain of number of electrons is called the respective electrovalency of the element.